DFG Science TV, Discrete Optimizers. Many roads lead to the destination. How math simplifies our daily life.
Many people think of mathematicians as rather weird and eccentric, spending the whole day playing with numbers and sums, but with no idea about what's going on in the real world. But the truth is quite different, because the main aim of mathematics isn't number crunching. Far from it. The most important thing is solving problems. That's what they're doing today, too. Our team of mathematicians has left their offices in Berlin and are on a mission to solve a problem. Today's problem is at the Kiel Canal, where their task is to develop algorithms to control the shipping traffic. Both the mathematicians and the canal's traffic controllers are contemplating the meeting that lies ahead.
We need to get a thorough and detailed understanding of what they actually do there.
We need to avoid using our technical jargon. We need to speak their language. I'm not sure whether the mathematicians really understand what we do here on the Kiel Canal. And in doing so, we need to concentrate on the real core of the problem. I'm not sure, but perhaps the mathematicians have a rather too theoretical approach.
We don't want our ideas to just end up filed away in a drawer somewhere. We want them to actually be used.
First of all, they need to explain to us how they actually control the ships. The researchers ask a lot of probing questions. In doing so, they often notice little details that could otherwise easily be overlooked. It is particularly important for the mathematicians to get an accurate idea of the task at hand on the ground, in order to be able to propose an ideal solution for the Kiel Canal's problem. Hundreds of ships pass through the Kiel Canal in each direction every day, but it's impossible for two large ships to pass each other. This means that one of them has to wait at one of the turnouts to allow the other ship to pass. The objective now is to minimize the total waiting time for all of the ships navigating the canal. After all, time is money. At the moment, the planning is done manually, even though the ship movements can now at least be tracked by computer. This electronic wait time diagram shows all of the ships that are currently navigating the Kiel Canal, distinguished according to size and speed. The planners hope that mathematical algorithms will make their work easier in future. The meeting lasts all day, and by the end, everyone seems to have learned something new. Wow, they really wanted to know all the details. The mathematicians are on their way back to Berlin and can already draw some initial conclusions. It was really great today. Yeah, mathematicians sometimes have a different view of things. I think I've already got an idea for a solution.
Isn't it a bit like route planning?
Over the coming weeks, the optimizers aim to develop a mathematical model for the challenging task of a traffic control system on the Kiel Canal. How will they set about overcoming this challenge, and what solutions will they come up with?
Visit DFG Science TV for more information. Awaken the researcher within you.